Okay, so this video is going to be on balancing equations and the examples. So it's going to be a little bit different than what we would do in class because we would focus a lot on going from the actual words of nitrogen gas, hydrogen gas, this silver solid reacts with, and to be all these words a lot of times, okay? And we would actually use those words to write the equation and then to go balance them. But based on the circumstances we're in, we are going to focus on, given the equation, how do we go about balancing it? The way I write it is a little bit different than the way some other teachers write it. So the first one, I'm going to show how I count up all of the atoms of each compound, and in the other examples, I'm going to do it how I believe other teachers may do it in class. There's no difference in the answer, it's just the way we go about counting the number of each. So when you're given an equation, or when you write an equation, these lines will not be there. But I think it's good practice to put them in so that we could see where the coefficients go. Okay, how do we go about balancing it? So the first step, we write the chemical formulas and the equations. Second step, we need to go about figuring out what we have within it. So for example, we have nitrogen here and we have hydrogen on the left-hand side. And over here on the right-hand side, we better have the same two. Now I went through this real quick in another video going over the notes, that these aren't negative signs, okay? It's just I put a little dash there just to create some space between the element and our number. So here we have two nitrogens. Okay. Here we have two hydrogens. Here we have one nitrogen and we have three hydrogens. And you can see that they're not balanced. So there's 2 and 1 and then 2 and 3. Right? So what do? Well, obviously we need to get nitrogens up to 2. The way to do that would be to put a 2 here. So now we take 2 times our coefficients, our subscripts. So 2 times 1 is 2. 2 times 3 is 6. And I showed this in another video. The way we do it in class, we say we just multiply these. Okay, coefficient times the subscript, coefficient times the subscript. But really what it's doing is it's saying that we have 2 of these. Okay, so if we have two of these compounds, there'd be 2 nitrogens and 6 hydrogens. Okay, you don't have to write this out, but I think it's just good to realize what's going on. So now we have our nitrogens balanced. Oh, but it messed up our hydrogens. It looks like even more, but not so. So what do we need to put in front of our H2 to get 6? What times 2 is going to get 6? And that's 3. Okay. So sometimes I've seen students do all this work on the bottom. This is just to keep track of things. The real answer is here. Now in class, I would require to see this because I want to see sort of the logic you went through and try to figure out what you did if you got it wrong. Okay? But in this case, there'd be a 1 here, but we don't need to write 1. It's implied that it's there. 3 and then 2, and it'd be balanced. Okay. Example 2. H2 and O2, that's hydrogen gas and oxygen gas, make H2O. Dihydrogen monoxide, but it's just water, right? So in the other classes, what they do, or in some other classes, they simply write what you have right down the middle. And on the left-hand side, they'll put the reactants, and on the right-hand side, they put the products. And, I grew up always doing it this way, but this way is pretty simple, right? Because what could happen up here is, like, sometimes students may put a hydrogen first over here, and nitrogen first over here, and they have a hard time figuring out, right, where the numbers go. In this case, it's pretty simple. On each side we have hydrogen, on each side we have oxygen. Okay. So on the left-hand side we have, I messed up there. we have 2 hydrogens, and we have 2 oxygens. On the right-hand side, left-hand side. On the right-hand side, we have 2 hydrogen, 1 oxygen. So our hydrogens are balanced, but our oxygens are not. Some students may try to do this. They might try to put a 2 in here, but you can't do that. You could only put coefficients in front of the compounds. So we have to put a 2 here. Okay? 2 times 2 gives me 4 hydrogens. 2 times 1 on the oxygen gives me 2 oxygens. So it balanced our oxygens, but it messed up our hydrogens. Well, that's a pretty simple fix. If we put a 2 here, 2 times 2, okay, so 2, 1, 2. And it's balanced. Okay, so those are the basics. I'm going to go ahead and write it like this from now on. It's pretty simple. So we're going to get into some where you see that we have these compounds together on both sides. That's fine. You'll also see that we have like silver all by itself. Whenever, one of the tips I always give is whenever you have an element that's all by itself, leave it till the very end, because it's always easy just to put a number in front of it to balance. Okay? So in this case we have silver, hydrogen, sulfur. Silver, hydrogen, sulfur. On the right hand side we have 1, we have 2, and we have 1. On the right hand side, I don't know if I keep saying, I can't remember if I say left side or right side, but anyway, on the right hand side we have 2. Now be careful, we have 1 sulfur and we have 2 hydrogens. Okay. So you'll see that everything is balanced except the silver. Well, that's very easy, right? We have 2 and we have 1, so this side needs to have 2. 2 times 1, 2, and it's balanced. It's hard to show what I call the little tips and tricks, okay, when we're not together, and we're doing just a ton of these together. But that's 1. You leave the 1 all by itself to the very end. Down here, we have magnesium, and we have oxygen on both sides. And so on the left-hand side, we have 1 magnesium, and we have 2 oxygens. On the right-hand side, we have 1 magnesium here, 1, right? I put those in there sometimes just so students could see. I wouldn't write those normally, but sometimes it helps the students just to see that. And we have 1 oxygen. So I need to get oxygens up to 2. So I put a 2. 2 times 1 for magnesium, 2. 2 times 1 on the oxygen, 2. Well, messed up my magnesium. Well, I put a 2 here. Makes that a 2. Okay, 2 times 1 is 2. So those are balanced. Making sure I'm not running out of room on the old iPad. Now here are some maybe more difficult looking ones. I'd pause it, I'd write them down, maybe give it a shot first, and then we'll do them here. Okay. So, iron metal, oxygen gas make iron 3 oxide, it would be. Make sure I got that right. Yeah, iron 3 oxide. Okay, I know that's weird, but this iron's a 3+ ion. Anyway, goes back to our naming compounds. So we have Fe and we have O. That's it. On the left-hand side, we have 1 and we have 2 oxygens. On the right-hand side, we have 2 and we have 3 oxygens. Okay, so this one looks a bit more messed up. Now, which one would I leave till the end? This one, because it has no subscript and it's all by itself. So how can we get these balanced? Okay. There's no way, see, the one thing we cannot do, I don't even know if you could see that, I wrote it so light. You can't say, well, I need 1.5. That would give me 3. I've had some students that do that and then they fix it in the end because they multiply everything by 2, but not good practice. So if we take a look at these, 3 and 2, what number would they both go into? 6. Okay. So how about if we got them both up to 6? So I'm going to put a 2 in front of this. So 2 times 2 would be 4 irons. 2 times 3 would be 6 oxygens. And then over here, I could put a 3. 3 times 2 would be 6 oxygen. See, now that's balanced. Okay. So at first it looks kind of difficult because we have an odd number and an even number, but really it's not too bad. And then lastly, we need to get the irons. I hate saying that word. The irons. Up to 4. So we put a 4. 4 times 1 is 4. Okay. Now, our next one involves polyatomic ions. If you recall, on the back of our periodic tables, or just look them up online, type in polyatomic ions, it'll give you a list. There are a bunch of grouped together polyatomic ions. So the mistake that students would do when they do this is they would say, okay, I have copper, and then they would write S by itself, and they would have sulfur. Okay, and then we have oxygen and aluminum. The thing to look at is you see how SO4 is a group. Now, I know other teachers say don't put this, but for now, I put these brackets around it, these parentheses, because I want to show that it's a group. See, SO4 and SO4. So what we're going to do is we are going to count those as groups. All right. And then lastly, we have, no, I wrote the same thing again. We have aluminum. Now that might not make sense what I just said about grouping them, but I think it will here really quick. So copper on the right-hand side, we have 1. Now how many total of this SO4 we have? Over here, we have 1. And on aluminum, we have 1. Somebody's going to say, wait, whoa, there's a 4 here. There's 1 of this group, and I think it makes more sense on the right-hand side. So let's find copper. It's over here. There's 1. Now let's find SO4. See this group, SO4? There's 3 of them. And then aluminum, there's 2. Okay. 1 group here, because there's nothing on the outside of the parenthesis. 3 of them here. Which one would I leave to the very, very end? Either aluminum or copper, because they're all by themselves. They don't have anything else attached to them. You can see copper is already balanced, but it's not going to be here in a little bit, and aluminum is not. So let's just leave those. Let's get SO4 balanced. SO4. What do I have to put here? A 3. So my copper, 3 times 1 on the copper is 3. Now see this? We're looking at the outside of our SO4. There's only 1 of them. 3 times 1 is 3. There's 3 groups of the sulfate. Always mix those up. Yep, sulfates. Okay. And so now we need to balance the aluminum and the copper. So let's fix this left side total up here. So 2, 2. Now these are all balanced. And then copper, 3. 3 times 1 is 3. So that's totally balanced now. So I always tell students, first thing I would do is I get anything and it starts to look really complicated. I'd be like, okay, are there any polyatomic ions? Okay. And then we just make sure we put the parentheses around them and we group them together. All right. So this is what kind of happens down here on number 7. We have aluminum hydroxide. OH is a polyatomic. It's pretty easy when it's already in brackets for you because there's 3 of them. Okay? Now over here, this looks kind of weird. Well, I kind of look over here and I see that this is what? Nitrate. Nitrate. And then, oh, OH, and there's an OH over here. So I'm going to put those in brackets. It just helps me do the accounting. How do I group these things together to make it easier? So on the left-hand side, I have aluminum, and I have a hydroxide. I have sodium, and I have a nitrate. And let's just check and make sure over here on the right-hand side. Dun, 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 dun. Perfect. Okay. Now sometimes, and I don't think it happens that often in the ones we do, is you'll find a polyatomic over here on the left, but there won't be any on the right. It breaks apart. Okay, it decomposes. And so you have to kind of throw that out and you can't use it anymore. You have to separate them. Okay, but in this case, they're on both sides, so that's perfect. Over here, aluminum, we have 1. Hydroxide, we have 3. There's a 3 on the outside of the parenthesis, right? Sodium, there's a 1 here, and we have a 1 for the I keep looking at my polyatomic ions, my nitrate. All right, and my aluminum, there's 1 over here, but where's it at? OH. Oh, we still have 1. Na, we have 1. And my nitrates, we have 3. Not because here, but look right here, there's 3 of them. Okay. Oh, how complicated. It's really not too bad. Pick a spot where you want to start. Okay? Let's just go right here. Let's get the OHs balanced. Okay. I have 3 over here. I need 3 over here. So 3 times 1, I got to do sodium first. 3. 3 times 1 on the hydroxides. 3. All right, well, that's great. Now it messed up something else. Well, let's try to do one of these then. Okay. Oh, look, they're both together. They tend to work out that way. They look real difficult to begin, then you'll notice, oh, wait, I could just put a 3 here. 3 times 1, 3. 3 times 1, 3. Okay. So those are our 7 examples.